Hi and welcome back to the lab. And today here on the bench we have an ICOM IC-9100. And the radio came in because it is deaf on 2 meter. So everything else is fine, but 2 meter has a sensitivity loss, and let's see what we can do. Okay, and here's our ICOM IC-9100, and yeah, it is already set to FM, and the radio operator told me that he is using it most of the time on FM, and repeaters which were very strong here on his radio, plus 120 dB or something, are now not really hearable. So the radio really seems to, from his perspective, to be deaf. So we are gonna check it right now, and well, I've already connected our generator to the radio, and I've set it to the sensitivity level or output level, if you like, where the radio should be able to produce 12 dB SINET. And well, so it is only static. And for your reference, so here are our sensitivity figures, and of course we are on FM, and 12 dB should be there if everything is fine with the radio. And here's our level on 144, so that means 2 meter, with input level of 180 nanovolt. The radio should be able to display 12 dB SINET, and of course with a bandwidth of 15 kilohertz, so that is for sure, but that are the figures, right? Okay, so look here, so we are sending into the radio 0.180 microvolt, which is a level where we should see 12 dB SINET, and we would see normally a nice audio signal, but we don't. We have our AF level, which is coming from the radio, is high enough, so that is all fine, but nothing happens. Okay, for me it is easier to work with dBm, so let me switch it over to dBm, and you see minus, yeah, let me say minus 122, so that is the sensitivity which we have in our specs, where we should at least hear something, and 12 dB means we really would be able to read the signal. Okay, now we does not hear nothing, so what can we do? Very simple. We simply increase our level until our SINET will reach our 12 dB, and let's see if we can get that. Oh, maybe you can now already hear a tone in the background. Anyway, let me increase it any further, because we have only, let me say, what is it, maybe 8-9 dB. Let me go until, and look here, so we are, yeah, we are here. I mean, don't forget, we still have noise, so that is normal, but we are reaching 12 dB, and what you see here is with minus 102 dBm. So what does it mean? Simply that we have a loss of sensitivity. So let me turn that down. We have a loss of sensitivity of 20 dB. All right, and that is really, really a lot. So, and that means that the radio operator is right when he is saying that he has a feeling that the radio is deaf. Yes, it is deaf. 20 dB is quite a lot. So that means we really have a problem, and we really need to look inside and see what we can do. But before we crack the radio open, we perform a total reset. I mean, that is always not very nice to the owner, because we are really deleting more or less everything what has been stored. But we really need to be sure that there is not something which may have been caused by an unfortunate setting here in the radio. So therefore, yes, not nice for the owner, but it is really necessary and able to know what's really going on. So therefore we switch the radio off, and we need to press F, E and P and M clear. So we press this both buttons, and now we start the radio once again, and you have seen all clear was mentioned down in our display, and that means really the total reset has been performed. And now of course we go back here to 145, and I've set my generator to 500, and yes, it is the same. So nothing has been changed in relation to the sensitivity, and that means there's really something wrong in our hardware. So let's go in. Okay, so radio is open, as you can see, and our starting point will be the PAB board, which is this unit here. So that is basically the PA board for UHF and VHF, and there we get from here our signal into the radio, and of course we need to start there. And here we have our RFB unit, where we have the first amplification, where we have at least our first mixer, and so forth and so forth. So that means we need to have a very close look to what we have down here. So let's start the testing. Okay, so that you got an idea where we are. So this here is our VHF pass. So we have different antenna inputs for UHF and VHF, and of course for SHF as well. So we need, of course, to follow our VHF pass, and we have here the first filtering, and the TXR RX switch, and so forth is on our PAB unit, and then it will be give over to our RFB unit, where we have, as you can see here, with Q1251. So there is our first amplifier, and of course that is an important test point for us. So let's start. Alright, so I start now here with my probe to go here through our unit, and I start here at our antenna connector and go over where we get our signal. You see we have here this antenna cable, and that goes over here to our RFB unit, and we check, of course, here to the RFB unit if we have, maybe, because there we have some switches and there's a little relay and so forth, and we check if we can see somewhere here a level loss. And then we are already on the RFB unit, and of course we go down to the first amplifier. We have seen in the block diagram what we had looked to. So that is how I do it, and I let you see the spectrum analyzer screen so that you see exactly the same like me. So my generator is set to minus 90 dBm at the input, and that is what I've showed you, what I've shown you before. So that is exactly our input pin from the antenna connector, if you will, and you can easily see in the upper right side the frequency one hand, and secondly you see that the level we have there is approximately 90 dB. So that is always not 100% because there is always a little impedance mismatch, but we can see minus 90.5 whatever, and it is changing a little bit. For us it is important to see that the level in general is there without a huge level drop. Okay, so we see that more or less here on the input of our PCB, and then I have here a little coil, and that is where I'm now, and there we have a loss of let me say 7 dB, and we have a lot of passive components here in this signal path, so that could be still fine, and we will check what it really means. Alright, so here on our RF board we have our first amplifier, and the amplifier is down there. That is our amplifier, so that is a little MOSFET. Okay, and what I found that there is no significant attenuation until we get here to the input of our little amplifier. And this amplifier, according to its specification, it should minimum amplify by 17 dB, but 70 dB at 2 gigahertz. So I believe with a lower frequency, what we definitely have with only 145 megahertz, then it should be, let me say and guess, 20 dB gain. So that means when I test at the input and at the output, I should see, I would say, approximately 20 dB gain, right? So we should have a stronger signal of about 20 dB. And that is what I want to show you. I show you input and I show you output. Okay, so what we see here is the input of our little MOSFET. Okay, so what we see is that we have approximately minus 90 dBm at the input. So that is what you hopefully can read in the right corner here of our display. Minus 90 approximately. It is always a little bit jumping, so that is normal. So according to our specification of this little MOSFET, it is approximately 20 dB gain. So that would mean behind this little amplifier we should see minus 70. minus 70 dBm is a higher signal, a stronger signal than minus 90. And you see that is the amplification of 20 dB, minus 70, right. Let me go now to the output of our little amplifier. And let me see, it's not so easy to get to the test point. And here's the test point. And yes, we have amplification, but it looks like that it is only 2 dB. So we see we have minus 88 something, whatever. So that is definitely more or higher than 90, minus 90 dBm. But that is only 2 dB amplification, and we are missing at least a lot. 18 dB gain is missing. And that seems to be part of our problem. The question now is this little chip faulty, or is there something different? Look, this is our little MOSFET amplifier, NE3509M04. So that is a low noise amplifier, N-channel HJ FET. Okay. Now, when we go here into the figures, okay, that is a super low noise figures, but what we see here, that is a gain of minimum 17.5 dB, typical at 2 gigahertz, okay? And we are not operating with 2 gigahertz, so we are much lower in the frequency, and normally that would mean that we have a little bit more gain, okay? So let me see if we have here another figure, and that is here. Here is a gain, right? And you see minimum 16. I hope you can really read it, right? Gain minimum 16, typical 17.5 at 2 gigahertz, and we only see 2. Maybe let's see this figure as well. So we have here our P out. That here is output power in dBm, and here is input power in dBm. They have tested it in two-tone input as also output, but anyways, so let's take here, let's say we take minus 20 dBm input, okay, and we go up here to our output figure or graph, then we see we are at approximately 0, and that is more or less our 20 dB, and with minus 10 you can see it is exactly the same. So it is always around 20 dB output gain, and you see again, so this is tested with 2.5 gigahertz. So that leads me to the assumption that there is a broken amplifier, one hand, or second hand, there is something wrong with our voltages around it. So let's check that. So here we have our FET, and look here, so at our R1261 we should read 3.56 volt. So that is simply the supply voltage. When we go over, we see here our VR8, so that is a voltage receive, okay? And we should see at the R1261 3.56 volt, so that is what we need, and that is something we should check. Okay, so let me go exactly down to that test point. Let me see, it is here. Okay, so look here, we have 1.6 volt where we should have 3.56, so approximately 2 volt too low. And well, what is causing it? Maybe our amplifier itself is drawing too much current because of a defect, or secondly, maybe there's something wrong with the voltage supply. So both is possible, so we need to investigate that a little bit more. Okay, as discussed, it could be our little field effect transistor, or of course you see here a little zener. And what we have checked before, that from or over this trace we get our 8 volt receive voltage, and I've checked that, so that is fine. So okay, maybe there is a problem here with our little zener, but on the other hand, what we could have else is that, you know, our little transistor is drawing so much current that our zener is not able to deliver. So, and then of course the voltage breaks in because we have a problem with our little transistor. So you see, let me think about what we do next. If we simply take one resistor off in order to see that we then have a right voltage, which would indicate definitely that we have a problem with the little transistor. And on the other hand, remember, so we have recognized that our radio is missing 20 dB of sensitivity. And if I'm right, and this little transistor should have a gain of 20 dB, then that would simply explain why we do not have the right sensitivity, simply because this little transistor does not really amplify. Alright, and I decided simply to take the little resistor out, because that is the easiest way to check. So look here, was our resistor, and here is the little coil. So now the resistor is out, and what we can do now, we can exactly test here at that point where we expect to see 3.56 volt for supplying our amplifier here, okay? And let's see what we see now when we check the voltage down there. Okay, so let me go down to that test point now without the little resistor in between. Here. Okay, so 3.8. Sorry, you have some reflections, I can see that. Sorry. And again, sorry, I believe now it is a little bit better. Not perfect, but a little bit better. Let me go back to the test point, and you see we have again reflections. Unbelievable. Is it my hand or what is it? Maybe, look here. Horrible. But now 3.88 volt is now available exactly where we expect the 3.56 volt, and that then is telling us that our little transistor is drawing too much power, because there must be a problem with it, and that is why it is not, you know, really amplifying. Alright, it's always difficult to test these little devices, components, but you see there is our little FET, okay? And when I go over, there is my tester, okay? Now let me start testing. Okay, so I think you can read it. Red and blue is shorted, and yeah, red and blue, you see it here, is shorted, and that is because we had a very excessive current draw, and that is the reason why we didn't get any amplification, or only a little bit. So we need a new chip, and then hopefully, if there is not something else, then the radio will back fine. We will hope the best. Okay, so we have a faulty FET, so that is for sure. And well, the radio is already a little old, and it is not so easy to get parts, but luckily I have two. Okay, so that should be enough. So let us put one into the unit, and let's see if the radio is then back happy. Okay, so what we see here is the situation on board. So here we have to place our little FET, and of course we have to fit in again our resistor, which goes into this spot here. So first, of course, we have to clean it, and then we start replacing the new FET. Alright, as you can see, everything is clean, and now we go ahead. Okay, as we can see, our new FET is in, and our resistor is back in, and it is almost clean. So that is nice, and that means we are almost ready for testing. Just another stop ago. Okay, so here's our radio working, but is it now in spec? Let's check that. Okay, once again, let's first check our figures, and we are on 144 megahertz, and we are testing on FM, and we expect 12 dB SINAT minimum if we feed our radio with 0.18 microvolt, so with 180 nanovolt. So with this level on 2 meter we expect, and with of course the big filter width, we expect 12 dB. So let's go over to the tester and let's see if that is true. Okay, so look here, we have 0.18 microvolt, so that is the level indicated in our service manual, and we are peaking up to 14, 15, but minimum we are always at 12 dB. So that means our radio is definitely back to specs, and that means it is back working on 2 meter, and that is what we wanted to achieve. And look, if we go now only a little bit higher here, so you can see that directly our SINAT is improving much better, so we can say the radio is really working just fine, just like from factory. Okay, and that means we're really at the end of our video. So another radio which is fixed and can go back to the operator. And so thanks for now, and Catch you next time. Bye.